finding the slope as far as a curve is concerned, it changes throughout. Like, all of these slopes are positive on this curve, but like these slopes are very small, getting pretty close to zero, and then all of a sudden up here you have a very steep slope. But how can I find the slope at a particular point? And let's just call this x value right here the point that I want to get the slope for. Well, on a line you had to have 2 points on the line, right? Well, let's look at that as far as this is concerned. We need 2 points on the curve. And again, we know, I'm just going to say this is y equals f of x. We know the equation for this line. So it's not going to be, or this curve, I'm sorry. So it's not going to be hard for us to plug in to figure it out, but we need 2 points on this curve. So what I'm going to do first here is I'm going to construct a tangent line here to this curve. And I'm going to call this point right here x plus h, which implies that I have some h value in here that I increased to get to there. So whatever h is, if I add it, my next coordinate here is x plus h, which means that this point right here would have a y coordinate of f of x plus h. So what I could do from that, and I meant to draw this earlier, it would be easier for you to have seen if I'd drawn it earlier. I've got this secant line that cuts through the curve in 2 places, right? So what I can do is I can get the slope of this secant line. And that would be changing y's over changing x's, right? So I've got f of x plus h minus f of x all over x plus h minus x. Well, numerator, there's not really anything we can do here, but f of x plus h minus f of x, what happens in the denominator there? Remember, this video is going to go viral. Y'all want to sound intelligent in front of everyone.
It's just going to be h.
It's going to be h, right? Okay. So we get f of x plus h minus f of x over h. So whatever those coordinates are, it would work here, and that would give us the slope of that tangent line, or that secant line. But is that exactly the slope right here? Not exactly. It's a good guess, but it's not the exact slope. So what we could do here is we could say, okay, well, I want to pick, and I need a different color marker here. Excuse me there, sir. I'm going to pick another point that's a little bit closer in. I hope the green shows up on the camera. But I'm going to move to right here. And I'm going to draw a tangent line here. And I'm going to connect those points. Well, do you see that this green line is a little bit better approximation of a slope than the blue line is? Kind of hugs the point a little bit better, doesn't it?
Between the points.
Yeah. So this is my new f of x plus h, which meant that I actually needed to move in. So now my h is here. So this is my new x plus h. And that gave me a better approximation for the slope. But I could still do better. And how could I do better?
Just get closer.
Move in my independent variable closer, right? Ultimately, what would I like to happen with that h?
It meets X.
You want it to meet x, right? We want this h value, or maybe not the h to meet x, but we want x plus h to meet x, right?
Yeah.
So if x plus h meets x, then what does that mean is happening to h? How small?
0.
0. We would love for it to be 0. We want to get it as close to 0 as possible. Well, what term in calculus have we used that referred to this concept of close to?
Limit.
Limit. So, what we're looking for, and this is called the limit definition of the derivative. The derivative is an equation for the slope. It's the limit as this h value approaches 0 of f of x plus h minus f of x all over h. So that is the limit definition of the derivative. It's important in order for the arithmetic to be accurate throughout. We're playing around with a lot of zeros in the denominator, right? So in order to keep it from being undefined, we have to keep this limit in here. If we take away the limit, then
It should be 0.
it's inaccurate math. It's undefined. So we got to keep the limit going in here. So, and I'm going to be picky on that. You're going to need to show this limit as h approaches 0 until there is no more h to approach 0 in these problems. But we'll look at an example in just a second.